Backyard Professor Math videos. It's a beautiful morning. I'm trying to get in before the sun comes up too high and causes a lot of bad reflections on my board. Let's continue learning how to graph linear equations. This becomes important because we've been practicing techniques up to this point on how to graph them, and now we're going to learn how to manipulate the equations. We're given two pairs of coordinates. This is the x, this is the y. X is always brought in first. Understand that. That's critical to keep this in mind when we begin using formulas to solve the equations. The question is, are these two coordinates a legitimate solution to this equation? 4c minus 3m equals 18. Does 3 and negative 2 work here? Now, when they give you a situation like this, when you find a situation like this, the x is always plugged into the first variable, but y, unless it's specified otherwise. So what we do is plug and chug. You remember the plug and chug. We have numbers, we have variables that we can plug the numbers into, so this becomes 4 times 3, we plug in x for c, minus 3 times negative 2 equals 18. Does that equal 18 is the question. 4 times 3 is 12, minus 3 times negative 2 is a negative 6. We are subtracting a negative 6, so we have a double negative, so we negate the negative, and 12 and 6 indeed is 18. So that's true. We know this equation has a solution of 3 and negative 2. That one is true. We always give the x first. So the next question is, given coordinate points 2 and 4, are these a legitimate solution to the equation 8a plus 7b equals 40? We plug and chug. This is the x, this is the y. I'm going to encourage you for the first little while to do this so you keep it straight in your mind. We plug in x at a, so this is 8 times 2 plus 7 times, and we plug in the y coordinate 4. This is going to be 16 and 28 equals 44. The equation asks, is 8a plus 7b equals 40 for these two? And it is not. It's 44. So those are not a solution to that equation. You see how that works? Now with this equation, y equals 2x plus 1, we're given 4 coordinate points, 2 and 5, 1 and 3, 0 and 1, and negative 2 and negative 3. And we're asked to put these coordinates in this graph and find the solution to see if these are solutions to this equation. So we want to find where these belong. So remember, x is always listed first, then y. So the x coordinate of 2 and 5. We come over here 2 on the x-axis. This is x, this is y. We come over 2 and we go up 5. So there's the 1 point, 2 and 5. And then we're given 1 and 3. We come over 1 on x and up 3. There's 1 and 3. We're asked to give 0 and 1. There's 0 and 1. You notice on 0 and 1, x is 0. You don't move to the right, nor do you move to the left. You just start on that axis and go either up or down. Up with positive, down with negative. 0 and 1 is 0 and positive 1. Right? And then negative 2 and negative 3. This comes down to here. So that we can see these dots are in a row. Negative 2 and negative 3. And what we do, and when you do this with graph paper, try to use a ruler because you do want to make this straight. On this chart, I'm doing it by hand. You want to connect the dots. And you want this graph to be as straight as possible. So let me see if I can draw a straight graph. Probably not, but there's our graph. With linear equations, why it's called a linear equation is because when you graph the equation with its various paired coordinate points, it's always a straight line. Linear equations, it's a straight line. We'll have graphs, there are graphs, to do a small version, that are parabolas. We'll have graphs that start here and take off way up on that side. We'll have all kinds of graphs that we'll learn eventually. For now, we're doing linear equations, and they always equal a straight line. Now, this is to our advantage because if we have a couple of points, let's say we're asked to say, is 3 and -4 a pair of solutions of this particular equation? We graph 3 and 4. We come over here, 3 positive on x, and then -4 down, 1, 2, 3, 4. We see this dot right here. We know this coordinate pair is not a part of the solution set because there's the graph right there, and all of these dots are connected to it. Any 2 points. Here's the interesting thing about linear equations. They have an infinite number of solutions. Not just 1 or 2 or 3. They have an infinite number because these numbers go out forever. So this line goes out forever. So that any point on the line, 2 and -1.5, or here's almost a -1/4, or -1/4 and 0. Any point on this line is a solution. Whatever numbers, and they can be fractions. You can have pairs that are 2 1/4 and -3/8. It doesn't matter if they're fractions. It doesn't matter if they're negative or positive. Any 2 points on these lines on the is a solution to it. So we can double check other coordinate points and see if those are part of the solution. If they don't fall on that line, then they're not part of the solution. -3 and 2 is not part of the solution to this equation, y equals 2x plus 1. We know -2 and 4 is not part of the equation. We know 3 and 1 is not part of the equation, etc. And this is valuable to know because this helps us double check ourselves to make sure we're graphing our equations correctly with the correct coordinate points. And that can be very important to do. Okay, we're told to graph an equation y equals 2x. This is what we want to graph. How do we graph it? One of the first things we do in an equation like this, we can choose any number for x that we want to choose. But we want to make a chart. Keep this simple and keep it clear so you don't get confused and you don't mess up your thinking here. X and y. If we choose a number, and then we'll have x and y, we'll have our coordinate pair here also. So we make a chart. If we choose the number 2 for x, what that tells us is y equals 2 times 2, because we've plugged 2 in where x is, and 2 times x is 2 times 2. So that means y equals 4. So we put that in the y column. We chose the number 2 for x just to get this process started. We're trying to find coordinate pair of points. So our first point is 2 and 4. And then if we choose 1 for x, 2 times 1, this says y equals, we're just plugging and chugging numbers into x, is 2 times 1, which equals 2. So when x is 1, y is 2. And there's another coordinate point, 1 and 2. When x is 0, then y equals 2 times 0, which is 0. So when x is 0, I have to extend this a little bit. When x is 0, y is also 0. You can see we're building up several pair coordinate points, right? Then when we choose x to be -1, y equals 2 times -1, which is -2. So when x is -1, y is -2, and there's another coordinate point. You notice how every time we're choosing a number for x and we're putting it first, then the number for y, and then in the coordinate pair, x is always first, then y. X, y, x, y, x, y. This is crucial to keep things easy. If we choose -2 for x, then our equation says y equals 2 times -2, which equals -4. Y equals -4 when x is -2. So x is -2, that means y is -4, and there's another coordinate point, 2 and -4. Now let me see if I can chart this. With the chart, once we've built up a correspondence, and you can choose any numbers for x you want. That's the beautiful thing about working on these. You can choose in this equation, you could put in 10,000, 10,014, 19,375, whatever number. But my advice is keep it simple. Just pick a couple of numbers in the positive realm, pick 0, and pick a couple numbers in the negative, and then you can keep the chart small. Because we're going to graph this equation, y equals 2x. We want to draw a graph, and I can't draw real good with this dry erase marker. I'm going to try like crazy. There's 0 and 0. There's our coordinate point 0 and 0 right there. In a rough sort of way, let's say this is 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is why I advise you to use graph paper. So we have one coordinate point. Another coordinate point is 1 and 2. So we'll mark 1 and 2 right there. Another one is 2 and 4. So you come over here 2 and up 4 in positive territory. Now we go to negative territory, -1 and -2. You go -1 to the left and down -2, because the negatives on this y-axis, this is x, this is y, the negatives are below the x-axis. And then we have -2 and -4, approximately there, so that you can see this graph. You connect the dots, and there's your graph. And I didn't get that dot, sorry. It's not an exact, you want to connect those dots. That's why you want a straight edge to do this with. This is enough to show you the illustration of how to graph by picking values of x so that we can discover what the values of y are step by step. You put your coordinate points in, then you take those coordinate points and put them on a graph and graph the equation. And then we label the equation. This equation is y equals 2x. It's going to be half of what 2 is every time. This is 2 times x. So y is virtually going to be half the value of x. And you can see that when double the value of x, sorry. X is half the value of y, because when x is 2, y is 4, which is twice as big. When x is 1, y is 2, which is twice as big, except for zeros. 0 is 0. But -1 is -2. Now, on the negative side, y becomes twice as small. -2 to -4. Now, going negative, it becomes smaller. Larger up to the right, smaller down to the left. So that's how you do these kind of equations. And we want to practice a few of these so that we get the feel for how to graph this stuff. And it's really cool to do. Now we're told to graph the equation y equals half x. How do we graph that? The same way. We want to make a chart of our x values, our y values, and the combination pair, the coordinate pair of x, y. X always goes first. And then we simply, to find the y coordinates, we want to choose numbers for x. Now we have a fraction here, so it's helpful, instead of dealing with the fraction, to use numbers in multiples of 2, since that's a fraction of 1/2, and then we don't have to worry about fractions in our chart, in our graph also, which is always helpful. So let's choose the number 2 for x. That means that y equals 1/2 times 2. We plug in 2 for x. So 1/2 times x equals y, so we plug it in here, 1/2 is 2. That means y equals 1 when x equals 2. And there's our first coordinate point, 2 and 1. You see how that works? Now let's choose 0. That means y equals 1/2 times 0. Any number times 0 is simply 0. So when x is 0, y is also 0. Now if we went with -2, that means y would equal 1/2 times -2, which equals -2 / 2, which equals -1. So when x is -2, y is -1, and there's our next coordinate pair of -2 and -1. And then if we choose -4, then y equals 1/2 times -4, which equals -4 / 2. 2 goes into -4, -2 times. So when x is -4, y is -2, and we put that in our chart. -4 and -2, and there's our next pair of coordinate points. Now we've built up 4 coordinate points, which is good enough to graph. You only need 2 points to make a graph, right? But we've got 4 here, so this is nice. So let's make our graph. Hopefully I can make this as good as possible. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You can label these positive 1, 2, 3, 4, 5, 6, a negative and positive and negative if you want. I'm going to leave it like that just to show you how to graph y equals 1/2 x. Well, we've done the work. We plugged in numbers for x and solved each equation each time for each number, and we now know what y is, and now we have our coordinate points. Now we plot these points on the chart. So let's do that. 2 and 1. We go over 2 positive on x and up 1 positive for y. There's our first coordinate point. Then we have 0 and 0 right there. There's our second point. Now we have -2 and -1. We're going to go down into negative territory on y, and then we have -4 to the left and -2. That's approximate. So we've plotted all our points, and you can see how to connect the dots to make the line, can't you? There's your graph. Whoop. Not a very straight line. Sorry about that. It's tough to draw on this dry erase board. But there's our graph. There's our line connecting each of the coordinate points. Now we can double check if someone was to come along and say, you know, though, another one of the solution pairs to this is 3 and -3. We can check that. 3 is always the x. The x is always first, x then y. So this is saying go 3 positive x and 3 negative y. So we go 3 positive x and 3 negative y, and there's our dot. But that dot doesn't land on that line, so that solution pair is not part of the solution of, and we always label the graph y equals 1/2 x. We know 3 and negative 3 is not a solution. We can test it. This is powerful, fabulous ways to double check ourselves to make sure we're doing our math right, is to see the visual of what the graph is doing. And this is interesting because it's going off to the right and it's going up. So this direction, the bigger values of x we choose, the more x we choose, the more to the right they're going to be. I mean, if we chose x as 50, then y would equal 1/2 times 50. It would equal 25, right? And 25 is way out past here. So that means that as this is going up at an angle, it's going to be much higher on the y-axis also. So you can see that this goes out forever. The bigger the number, the taller that graph gets. And we can virtually check to our heart's delight thousands of solutions if we need to. That's a fascinating thing, isn't it? So this is the idea of graphing. We're going to practice a lot of these, and we're going to learn how to explore all kinds of linear equations with variables. And we're going to practice graphing, we're going to practice charting, and we're going to get familiar with this because we're going to be doing this a whole lot in all of math from now on. So that's what I wanted to show you today. Have a great life. Happy calculating. This is the Backyard Professor in amongst the cows in the mountains. I'll see you in the next video.